All right. So, first thing is that internet is a group of computers connected together, and they share information with each other, um, and over a network. So it can be a wired network or a wireless network. So we don't want to, we can't have wires all over the world. So we have, thank God, we have wireless network, wireless communication. So yeah, so it helps us, communicate wirelessly. So when I go to a site like www.youtube.com, what happens is that YouTube is simply a computer, but now because of it serving millions of people in the world, YouTube is a bigger computer. So YouTube is this big computer sitting somewhere here, right? YouTube server. So YouTube is this big computer sitting somewhere here, and um yeah, let's make it long. So YouTube is this long big computer sitting somewhere here, and it has a video that I want to play. So this guy is uh Mr. A, right? Mr. A has a computer too, a device, let's say a mobile phone that is sitting here, and Mr. A wants to get some video from YouTube. Now, if Mr. A's device and YouTube server were very close to each other, they would just YouTube would just send the video to him through via Bluetooth. But now YouTube cannot do that because YouTube is far, far, far away, so he cannot send the video really quickly. So he has to chunk the video into bits of data and send it and rearrange it on this guy's device. So now all that now because the distance between this guy's device and YouTube is really long. Let's say this guy is here in Nigeria and YouTube server is okay, you know what, let's take this guy here. So and YouTube server is somewhere all the way here, somewhere in America. Now there's a problem because even wirelessly these guys cannot connect. So usually what we have is we have a guy in the middle who is going to be our router. So first of all we have um uh, different routers. So for you to stream a video from YouTube, you can't even use one router, right? You need different routers. So first of all, so let's say you're in Lagos, you have a router in somewhere in okay, anywhere in Lagos, Ojota. Now you have a mast in Ojota, and this mast has a router on it, and this mast takes the request of the video you want to play from your device, sends it to another mast somewhere, probably in Abuja, right? Let me duplicate this. Yeah, so somewhere in Abuja, sends it to another router somewhere on the sea, and then a long cable comes in and plugs everything all together, right? So let's say this is that cable, right? And this is the border of the whole of Nigeria. So let's draw a border here. So we have a border here. Oh, sorry. Okay, good. So this is good. So we have a border here, and that border, we cannot install routers on the sea because to install a router, we need to install it on a mast, and a mast is needs to be put in the ground, and it's very expensive to start putting masts on the sea. So we just use a simple cable, a simple fiber optic cable or a couple of cables. And so when so let's go back to this Mr. A. Mr. A wants to watch a video, right? In internet connection, we have something called request and response. Request is you are requesting for a resource. Response is the resource that you're getting back. So Mr. A sends a request to www.youtube.com. Now this router figures out, okay, what is www.youtube.com? What IP address does www.youtube.com connect to? So every computer has an IP address, and YouTube server has an IP address. I think I'm talking too fast. Okay, so YouTube server has an IP address, and um, this router figures out what the IP address is, because every router has like a list of domains and their IP addresses. There's a way they store them. Um, yeah. So this router says, okay, the IP address is at 1.4.4. So a route, so it tries to figure out, okay, where is 1.4.4? So 1.4.4 is in America, and is in X location in America. Okay, so how do I get this real request to 1.4.4? So the routers have an algorithm that they use to calculate the nearest distance and shortest distance. So this router will calculate the shortest distance to 1.4.4, which is this YouTube server. So this router will send a request to this router. This router will send a request to this router. This router will send that request to the fiber optic cable, and then boom, YouTube server gets the request. YouTube server will now say, okay, so you want to play this video. So let me take 5 seconds of that video and send it to you first. So YouTube server will send 5 seconds of that video, route it back to the user. The user would see it. YouTube server will send another 5 seconds of the video. So it keeps sending 5 seconds of the video till the whole video is complete. So that's how YouTube server will give the response. So this is a request and response scenario on the internet. Now, how do we replace these guys, right? These are bad guys. This MTN and Airtel and Glo masts. It's very simple. We don't need to buy the infrastructure, right? Because we don't want to be a telecom company. The moment we start buying up these masts and start installing these masts everywhere, we are technically a telecommunication company. So we don't want to be a telecommunication company. So what do? Now we simply turn these users into routers. So first of all, we eliminate these guys, eliminate these guys, eliminate these guys. So the okay, yeah. So we have eliminated those guys now. Let me 1 second. Okay, so we've eliminated those guys. So how we eliminate the masts of these big telecom guys is simply by making the users the routers, because we need routers anyways. We need to route these requests and responses, within Nigeria, to YouTube. So let's not talk about how we would eliminate the fiber optic yet. Let's just talk about how we'll eliminate the big masts from the telecoms first. So what we do is we have another user. This is Mr. B. We have another user. Sorry. This is Mr. C. This is Mr. D. So I think this is enough. So this is Mr. E. Right? Mr. E. So all these guys are users. This guy is using a laptop. This guy is using a phone. This guy is using a television, a Google Chrome television. This guy is using another device. This guy is using a mobile phone. Right? So all these guys want to connect to the internet, but right now there's no mast. So what they do is in front of their house, in front of their houses, or in their offices or whatever location they are, they have this DSTV satellite. So DSTV. This DSTV satellite is a very powerful device, right? This one. Now this dish as you're seeing this dish has the ability to connect to a satellite in space. Like, that's literally how DSTV works. I've read about DSTV company. DSTV company has a couple of satellites in space, and they rent out they rent other organizations' satellites in space, and they use those to deliver information to us. So all the TV channels we watch, all the MTV base, all the sound TV we watch, we're getting it from space. So these satellite companies, DSTV, basically this technology, as you're seeing it, has the ability to receive information from space and to send information to space, which is basically what we want, right? So now people are simply going to have this in their houses, only that it will not be DSTV now. It will just be called, our company's name, or it could have no name on it, or however we choose to do it. So now, once we have, agreed that all these users are going to have that device, right? And then inside their houses, they will also have a device like this, Wi-Fi router. So, bad internet. Okay, thank God. Yeah, so they will have a device like this. You'll probably not have antennas, but it'll be a small, lightweight device. They'll have a device like this in their house. So they'll have this and a satellite dish, which is not going to be very expensive. We're going to keep it under a few thousand nairas. It's going to be the same price with DSTV's stuff. So you buy that once, and now all these users have these satellite dishes, right? So now Mr. A wants to watch a video on youtube.com. So he types in youtube.com and clicks the video. Now a request to be sent from this router to this router. So don't forget, these are not masts, but these are users. So now we're using the internet users, as routers. So this guy's dish, without the permission of the user, just this will be going on behind the scene, would send a request to this guy, right? This guy would send a request to this guy, and this guy would send a request to the to the fiber optic cable device. And same goes for the YouTube server. Will send a response back, and then this guy gets his videos. So basically, with this, we have eliminated the use of masts, literally. All you need is to have, and again, these satellite dishes, they are very powerful, right? They can send signals like, so many kilometers away. And I'll probably get the exact figure of how many kilometers, it can send signals, radio signals over. I don't know if it will be, we'll just calculate the most efficient distance, but it's going to be very, very long, very long. So in this system, once we have two devices over the span of, let's say, 1 kilometer, it's good to go, right? So this is one way of routing through the users to the fiber optic cable, and then to the server we're trying to connect to, which is the YouTube server. Now let's remodify this whole architecture again. This time we don't want these guys to route between each other, and then we don't want the fiber optic cable. So now let's eliminate the fiber optic cable, and let's eliminate the connection between these guys. So we don't want no connection between these guys. You guys don't need to connect with each other anymore. No more connecting with each other, right? Now we are also removing the border, because now we're making it borderless. So YouTube is here, devices are here in Nigeria. This is the border. They need to connect to youtube.com, YouTube server, YouTube's IP address here. this is where this is now this is the architecture and pattern that I pick. This is what I think will work best for us. Probably in a few weeks or something, we can modify it, come up with something better. But this is what I think would really work. So we have a satellite launched in space, not just one, a couple of them, right? A couple of them. Sorry. So I have a couple of them, right? Launched in space, and they are they're just there in space now. So we have so many satellite companies in the world. I don't really trust Chinese, but so we have Chinese satellite companies, we have US satellite companies. In fact, SpaceX could help us, launch this thing. But basically, we have to launch it undercover. We're not going to launch it from Nigeria. We're going to launch it from another country into the orbit or somewhere, into the orbit of, Nigeria. So currently, Nigeria does not have regulations restricting another country from launching a satellite into its orbit. That's the thing. These guys, these politicians are not that smart. They don't know these things. They don't have regulations to cover these things because there's no money in these things. They don't really understand it. They haven't figured it out. Once there's money in it, they'll start to think about it. They'll start to look at it. Or once they understand the risks they are in. So now we have satellites, and what is going to happen here is we don't need routers anymore because each of these devices can connect to the satellite, just like the way you have in DSTV. Your DSTV satellite sends a signal, right, to the DSTV. Your DSTV router sends a signal to the DSTV satellite in space, and the DSTV satellite in space sends back a signal, with all the video data encoded and streamed to your device, and then you're watching it on your television. So Mr. A wants to watch YouTube, www.youtube.com. It connects directly to one of our satellites. This satellite is in Asia, right? Let's say Asia is closer to Africa, and this one is in America. So the satellite in Asia would send would propagate the signal to the satellite in America, and the satellite in America would take the signal to a fiber optic cable, because don't forget, America already has their own infrastructure for fiber optic cables, which is good, and they have good regulations and easy ways for us to get it. So all this YouTube and all these things, everything is connected to the fiber optic cable. Everything you can get, once you are connected to the fiber optic cable, you are connected to everything in the world. So this satellite sends information to another device that's going to be like a receiver device. This device would now send information to the fiber optic cable. So there you have it. We have plugged this guy from here in Nigeria to this server in the US. Same thing with this guy. This guy wants to send information. He sends it to the nearest satellite, which is this guy, and then this guy sends it to this guy, and now it's connected to youtube.com. Same thing with this guy, same thing with this guy, same thing with this guy. So literally, we don't actually need masts and all these 4G masts everywhere. We don't actually need it. Everybody can connect directly to the satellites. Now, if you might ask that, okay, so if this is possible, by the way, this is not actually easy. This whole thing I've said is pretty expensive. The software for the satellites, we don't want someone else to control the software for our satellites, so we want to build that ourselves. So we're going to be building that, not from the ground up, but we're going to be very involved in the building of that. We'll probably take an open source code or something that's already built, or we can even build from the ground up. So we build our own satellite software, and we launch it into space. We launch that software into the satellites, and the satellite and the company we're partnering with helps us to launch it into space. So the software is going to cost, the building the dish is going to cost. Again, we'll partner with a manufacturing company to build this dish and these routers. customize it to our company's name and our network, and make all these softwares work together. So it's way cheaper than what MTN and Glo and Airtel is doing now, but it's not exactly that simple. It's not a thing anybody can just wake up and say he wants to do. You need expertise. You need the best people to work on it. So hiring the best people is going to be another challenge, but it's something we can work on. We have pretty smart people in Nigeria. We can always hire a mix of teams, some from Nigeria, some from Asia, some from America. Just have a touch of everybody with different experiences in different companies and put them together to build it. So, another reason why this is not done in the US and in Asia and other places is because in the US, companies like AT&T already exist, right? Internet companies in the US already exist, and they are using the traditional method, which is having a 4G mast connecting to the 4G mast, and the 4G mast connects to the fiber optic cables and to the rest of the world. That's what America is using currently, 4G. And if you think of it, why would AT&T go and restructure the whole internet in America? Like, that's very hard to do. You can't restructure the internet in America. That's why even 5G, it's hard for 5G to get a foothold in America, because telecom is not something that you just wake up and change. You can't change the infrastructure people have been using for years. That's really why they are not changing it. But if you can take a read at what SpaceX is trying to do with the internet, um, it's similar to what we are trying to do here. So they are also SpaceX, because SpaceX is has mastered the art and the skill and the technique of and the technology of launching satellites. They It's very easy for them to say they want to do a thing like this because they already launched satellites. So already SpaceX has internet router satellites in space, and nobody knows what they're going to use it for commercially, because the US is not as if the US needs faster internet or anything. That's really the challenge for SpaceX. Would people, um, not just the people, would the government agree to restructure their internet? Their society is different from our society. It doesn't just They can't just restructure the whole of American internet to start working using SpaceX internet. There's a lot of politics and other stuff that go on, and this is faster than traditional 4G internet. So communication between the devices and the satellite to these devices to the satellite is faster than communication between your mast in Ojota, from there in Ojota to the one in Abuja, from the one in Abuja to the main one fiber optic cable, from the main one fiber optic cable to the US fiber optic cable, from the US fiber optic cable to the US 4G router to www.google.com. That's a long journey. But this internet just makes it a three-way journey. 1, 2, 3, and you are in google.com, right? So yeah, so I think this is really good, and we can come off as a blockchain company and not a telecommunication company. And once we have good lawyers to argue that out, we can always, spend a lot of time, stall in, all these things take time. So while they're taking their time trying to figure out what we're trying to do, we are already making money, we're already on the move, we're already building our technology, and we've already gone to market. And by the time they now say, oh, now you must get a license, the public already knows that our internet is way, 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 way better than what they currently have, right? We can go 1 gig per second with this type of internet. 1 gig per second. Of course, if you want me to get the exact figures, I'm not a I mean, I'm a solutions architect, but I don't have specialty in one particular field. So yeah, I'll need to work with engineers to come up with those figures. But I can tell you, we can go, from what I've seen other companies do, we can go 1 gig per second with this space type of internet. So this is what I call 6G actually. 7G is different, but this is what I call 6G. And yeah, so that's it basically.